Engines roaring, car racing and drifting, a blur of motion and power. It's a spectacle we associate with the modern world, but the roots of this revolution in motion reaches back to a pivotal moment in history, the birth of the internal combustion engine, also known as ICE. During the first industrial revolution, steam engines were the main source of power for transportation. However, as the 19th century approached, a new engine emerged, one that would redefine industry, transportation, and daily life. This was the era of the Otto engine, the first commercially successful internal combustion engine invented by Nicholas Otto in 1876. What set the Otto engine apart? Its predecessor, the steam engine, was bulky, expensive, and slow to start, and were primarily used in trains. The Otto engine, on the other hand, was compact, efficient, and practical. It operated on a 4-stroke cycle, which is represented by the intake, compression, power, and exhaust. The key innovation of compressing before the injection of the gaseous gasoline mixture was what allowed the Otto engine to achieve greater power and efficiency. This innovation enables the engine to be safer, more convenient, and versatile. Its ability to be started and stopped at will and portable size thus also made it feasible to be installed in small workshops. Therefore, the Otto engine made mechanical power accessible for many. Hence, it laid the foundation for the modern internal combustion engine, permanently changing transportation and industries worldwide.
Henry Ford's success did not stem from invention alone, but his ability to integrate and scale existing ideas into a coherent, self-reinforcing system of production. Drawing on Adam Smith's concept of the division of labor, Eli Whitney's principle of interchangeable parts, and Frederick Taylor's scientific management, alongside his own observations of Chicago meatpacking lines, Ford developed a model that not only revolutionized manufacturing but also reshaped American economic and social life. Inspired by the wealth of nations, Ford's model was built on the concept of division of labor. Ford broke down car assembly into highly specially repetitive tasks. The assembly of the motor, formerly done by one man, is now divided into 84 operations. These men do the work that 3 times their number formerly did. This allowed for rapid onboarding of unskilled workers, reducing training times, and greater control over output. While efficient, this regimented structure also reduced worker autonomy and made labor more monotonous. Scientific management reinforced this system. Though Ford never directly cited Taylor, his practices embodied Taylor's principles. He used stopwatches to analyze every motion, discovering, for instance, that nearly half of a worker's day was spent walking. Ford even insisted that machines be pushed beyond manufacturer's specifications. The result was an extremely productive but physically taxing environment. As Charles Madison recalled, he was too fatigued after leaving the Ford factory to do any serious reading or attend a play or concert. Yet this intensification of labor came alongside rising wages and improved working conditions. In 1913, Ford workers earned about 30 cents an hour while working 66 hours per week. By 1920, wages in key heavy industries were influenced by Ford and wages had more than doubled, reaching 57 to 67 cents an hour. While working hours declined, skilled trades saw even steeper gains. In Chicago, bricklayers earned 75 cents an hour in 1913 and 162.5 cents an hour in 1929. Without an increase in hours, these wages increases were not accidental. They reflected Ford's recognition that mass production required mass consumption. Ford's Model T became increasingly affordable for the working man. Average wages in the industry rose, while the price of the Model T fell dramatically from $850 in 1909 to just $360 in 1916. This price drop coincided with internal cost efficiencies. Between 1909 and 1916, production costs per vehicle fell from $590 to $262, while output exploded from 13,941 units to 585,400 units. Ford's deliberate cost restructuring reduced overhead and material expenses while emphasizing labor, effectively turning workers into consumers. The moving assembly line, introduced in 1913 at Highland Park, was the centerpiece of its transformation. It cut chassis assembly line from 12.5 hours to under 6, and overall labor hours per car fell from over 400 in 1910 to 123 by 1915. Workflow improvements like reducing engine block movement from 4,000 to 334 feet using gravity slides and monorails also contributed. These efficiencies not only lowered costs but stabilized the workforce. The record-breaking $5 workday for the common man introduced by Ford in 1914 further strengthened Ford's workforce and his factory. Turnover, which reached a staggering 370% in 1913, dropped to 16% by 1915. Absenteeism fell from 10% to 2.5% over the same period. By pairing higher wages with stable employment, Ford cultivated loyalty, reduced training costs, and ensured a dependable consumer base. To sustain this pace, Ford relied on interchangeable parts, a concept drawn from Eli Whitney but executed at an unprecedented scale. As Ford proudly stated, Model T parts were interchangeable with similar parts on all the cars we have turned out. This allowed for seamless assembly and repair, reduced inventory costs, enabled unskilled workers to perform precise tasks without custom fitting. It also supported economies of scale critical to affordability. The ripple effects of Fordism extended into urbanization and infrastructure. As car ownership expanded, cities were restructured. The share of Americans living in urbanized counties rose from 25.4% in 1900 to 36.3% by 1920. Road access and affordability improved dramatically. In Illinois, the ratio of population to registered vehicles fell from 158.6 in 1910 to just 11.4 in 1920 and 4.6 by 1930. Cars changed not just how people moved, but where and how they lived. Ford's most profound contribution, however, was recognizing the need for a self-sustaining industrial ecosystem where worker, wage, product, and market formed a continuous loop. The success of a large-scale production depends on the ability of the population to buy in volume, so said Ford. In Ford's vision, production did not end at the factory door, it extended into homes, roads, and consumer habits. This systemic insight eluded imitators, particularly in Nazi Germany. Though Volkswagen engineers visited Ford's River Rouge plant and Hitler promised cars at 990 Reichsmark, cheaper than Ford's, the regime failed to replicate the full model. Wages remained suppressed to fund militarization, infrastructure lagged, and by 1938, only 1.3% of car buyers were workers. Cost of fuel and maintenance rose, further undercutting access. In contrast, to Ford consumer worker, Nazi policy disempowered its labor force. In conclusion, Ford's legacy rests not in any single innovation, but in his holistic integration of production, labor, and consumption. His success lay in aligning technical efficiency with social design, creating a feedback system where better jobs fueled greater output, and greater output sustained more consumers. By combining these ideas, Fordism changed the way modern capitalism worked and became a model and standard for industrial development in the 20th century and even 21st century.
Since the early 20th century, the global race to expand the internal combustion engine capacity reshaped the labor markets and national economies. As countries strived for industrial dominance through total horsepower output, this competition for expansion was not only symbolic, but it led to the widespread creation of jobs and shifted the structure of how economies operated. From 1899 to 1923, in the United States, the average horsepower per wage earner increased sensationally. In the manufacturing industry, wages increased from 1.4 to 3.76. In the mining sector, wages increased from 3.36 to 6.52, and in agriculture it grew from 2.32 to 4.74. This increase in mechanization showed a higher capital investment in internal combustion technologies, which echoed a nationwide drive to boost productivity per worker. As a result of the growing horsepower per capita, it created the demand of a large number of labor roles, not only limited to only operating machinery, but in areas of design, production, fueling, and maintenance of the internal combustion engines. This expansion of mechanical power reshaped the workforce as it shifted employment opportunities in the direction of logistics, manufacturing, and engineering, and further away from traditional manual labor. The circumstance did not only occur in the United States. Illustrated by the Clerk in 1916, the scale to which the engine race became international. By 1909, the United States, the United Kingdom, and both Germany and France led the world with an contributed estimate 2.5 million, 1.53 million, and half a million horsepower, respectively, in the combustion engine output. This competition was a representation of a deeper geopolitical contest where combustion power of each country represents the progress and international strength of a country. Such examples were British manufacturers such as Crossley Brothers single-handedly produced more than 1 million horsepower of engines in the early 1900s, outdoing many German manufacturers, which demonstrates the connection between the economic capacity and engine output. This massive growth in production contributed to the creation of jobs in a variety of sectors, from assembly lines to fuel supply chains. Engines also emerged to consume a variety of fuels such as petrol, coal gas, benzol, wood waste, and alcohol, with each of them requiring its own unique way of extraction, distribution, and processing. This resulted in a mutually dependent network of employment that extends far beyond traditional factory work into the rural supply, energy, and chemistry industries. Through mechanization with internal combustion engines, it allowed for small businesses like farms to gain access to power for the first time, scattering industrial capacity and evening up economic participation. The emphasis that even the smallest internal combustion engines facilitated the simplest of operations to become more productive. This opened opportunities for small entrepreneurs and increased rural employment flexibility. With the increased usage of engines in the agricultural industry, where 98,785 horsepower in the United Kingdom's farming in the early 1900s, it aided the higher output with fewer labor workers, ultimately pushing traditional rural workers into urban industrial centers. This shift in workforce ultimately led to a totally new urban working class and a reshaping of labor distribution across the country. Similarly, with the accelerated growth of usage of motor vehicles, with France and the United States having produced 46,000 and 115,000 motorcars by the early 1909, it created a pathway for a new customer economy and sped up the demand for mechanics, drivers, and roads. Therefore, the internal combustion engine thus created a chain reaction across the society with the transformation of mobility of people, infrastructure, and social identity.
The impact of internal combustion engine on agriculture, social, and economics. The internal combustion engine proved to be technological background whose adaptability impacted diverse vehicle platforms that influenced the social and economic transformation across the 20th century. In the area of personal transport,
the mass-produced and affordable car installed with continual IC refinement systems and assembly line efficiency liberated families from being confined in one area. Due to the affordability and benefits, there was a massive demand for the vehicles and factories' production rate had to increase. From 1933 to 1936, the production for vehicles doubled in numbers. However, in 1938, the production decreased significantly due to US recession from 1937 to 1938. The community daily life revolved around commuting by automobile. This fueled a new consumer market for motel, gas station, roadside diners, insurance services, etc. Moreover, the ICE-powered automobile replaced horse-drawn wagons, enabling faster and longer distance of delivery movement, which ensure the preservation of perishable goods. In addition, ICE standardized the distribution system and began the inventory models. This connected the regional and national market more tightly, which catalyzed a boom in highway construction, warehousing, and logistics sectors. In 1900, inline V-twin engine was produced, and engineers came up with new car, bike, airplane, and airship designs. The new motorized vehicles were mostly adopted by younger and lower income riders, and it also gave rise to new subculture like racing and custom engineering. Furthermore, the production of motorized vehicles gave birth to specialized industries for parts, outfits, and accessories. The new plane airship design gave rise to services from meal delivery to long-distance passenger airline. This new service from passenger airline reduces the global travel time significantly from weeks to a few hours, which foster international business networks, tourism, and cultural exchange. Furthermore, the aircraft design established military air transport that provided strategic military assets for rapid troop movement and logistics support. The internal combustion engine also revolutionized agriculture sectors in terms of machinery. For example, the cotton industry was relying on team of mules and farmers to till and plant the field. But after ICE was invented, factories started to produce ICE power tractors to help the agriculture industry to break ground with efficiency and consistency. The ICE tractor is able to prepare dozens of acres in the same time it took for a team of laborers to manage a single plot. In addition, the ICE was also used in invention of mechanical cotton pickers that replaced the painstaking process of hand-picking cotton done previously by the artisan crews. By replacing these small-scale manual operations with one-man machine, farmers were able to slash labor costs and dramatically increase their yield over time. As farm workers were freed from back-breaking fieldwork, many changed professions to industrialized society due to the rise of the machine age. At the same time, a network of fuel supplier, mechanics, and part dealers sprang up as tractors came rolling into the agriculture industry. This impact laid the groundwork for modern agriculture business and transforming farming into a capital-intensive and technology-driven enterprise. Collectively, these ICE-powered vehicles went beyond their mechanical usage to reshape labor markets, human settlement patterns, leisure habits, and geopolitical dynamics. For the impacts of geopolitical dynamics, suburbs emerged as the commuter belts, rural communities were integrated into regional economics, supply chain was streamlined to meet just-in-time demands, and the globalization of trade and travel accelerated. Economically, the ripple effect of ICE production generated enormous employment, not only within the automotive and aviation factories, but also in industry that produce steel, rubber, glass, and petroleum.
Since the emergence of autocycle and the widespread distribution of ICE cars around the world, thanks to Henry Ford's brilliant assembly line, there was a significant increase in demand for gasoline. One huge oil company took advantage of this and shifted its focus from kerosene to mass refining gasoline. This company was none other than Standard Oil, which was founded by John D. Rockefeller. At that point in time, Standard Oil already controlled most of the refining and distribution networks, and this boom in gasoline cemented its power, allowing it to dominate the oil industry even more until its breakup in 1911. Before we delve into how Standard Oil contributed to America's booming economy and subsequently its downfall, we need to understand the reason why the company was successful and how did it manage to monopolize the oil industry. By relying on its superior efficiency alone, the company managed to overcome most of its competitors by 1870. This meant that a company as big as Standard Oil would have no issues expanding or transitioning their business to refining gasoline. However, this was not enough to put the company at the apex of the market. To make sure Standard Oil stays on top, it had to resort to secret agreements with railroad companies that gave it discounted shipping rates, allowing the company to cut transportation costs and undercut its competitors. From the table, we can see that Standard Oil paid around 35% less than its competitors for shipping crude and refined oil. This advantage allowed Standard to transport more oil without worrying about the miscellaneous fees incurred. Another reason why Standard continued to flourish in the oil industry was because it exerted monopoly power by intentionally destroying open oil markets to centralize price setting power and suppress producer cartels. To put it simply, Standard Oil eliminated competition by buying majority of the crude oil and limit the producer's ability to sell to anyone else because Standard also owned pipelines aside from the decrease in railway fees. This allowed the company to take control of the market and set the price for oil itself, and effectively shutting down public exchange. This regression table summarizes how Standard Oil's control over transportation and its suppression of producer cartels significantly lowered crude oil prices, helping it to maintain monopoly power. We can see that when producer cartels work together, the net price of oil increased by 40% to 52%, but Standard used its power to reverse those effects, meaning the end cost remained relatively low. As the ICE started to take off between the late 1890s to the early 1900s, oil output began to rise as well, especially in America as seen from Table 1. Between 1865 to 1885, the amount of oil was increasing slowly but steadily. Subsequently, in the following years, the amount increased exponentially, with the biggest jump in oil production occurred between 1899 and 1904, where the index more than doubled, a 105% increase in just 5 years, or an average 15.4% annual growth. This period marks the most rapid expansion, highly likely tied to the mass adoption of internal combustion engine vehicles and expanding industrial uses for oil. In Table 2, we can see the total value of crude output. Although crude oil production value fell from 24 million in 1869 to 17 billion by 1879, it later soared dramatically, reaching a whopping $214 billion by 1914. Both statistics showed that the biggest increase of oil started from the late 1880s till the early 1915s, which aligned with the timeline of when ICE was gaining traction. This suggested that amidst the unfair competition between Standard Oil and other oil companies, there was also widespread economic activity. The expansion of oil drilling, refining facilities, pipeline infrastructure, and the coming of Ford's assembly line required a large workforce to operate, hence leading to a substantial increase in job opportunities across the oil sector. Again, in Table 14, it shows that the number of wage earners climbed the most during 1899 to 1904 from 12,000 to 18,000, which later increased to a staggering 31,000 people by 1914. However, as automobiles powered by ICEs became more common in the late 1890s and early 1900s, gasoline transformed into a high-demand commodity. This surge in demand triggered gasoline price inflation from 7 cents a gallon in 1899 to about double the amount within a year. By 1902, it had reached 18 to 20 cents a gallon, reflecting how quickly ICE can reshape markets. as with most other resources, once there is a demand, the consumer cost of that resource will be affected. Gasoline overtook kerosene to be the most profitable product in a market, and with the spiraling growth of oil production, it was no wonder that this event incentivized further investment and competition in the oil industry, with Standard emerging at the top due to its reputation and tactics at the time. Standard Oil's early dominance in refining, transportation, and distribution meant that when the demand for ICE exploded, the company was already equipped to supply 65% of the world's fuel at a national scale, effectively enabling the economic boom not just in America but the entire world by allowing countries to power ICE-powered technologies from the oil that was exported. For example, the British received a little over 62% of the oil imports from the US, while the remaining 38% comes from other countries like Russia and Romania by 1913. However, the reign of Standard Oil did not last long. The emerging ICE fuel economy prompted government intervention in the form of antitrust legislation, specifically the Sherman Antitrust Act. The purpose of the Sherman Act was to promote economic fairness and dismiss unfair competition in the marketplace. Although the act was enacted in the 1890s, it lay dormant for 20 years against huge companies until Standard Oil case was finally put into action in 1911. The reason why the act was ineffective at the start was because the rule of reason specifically meant cases that involved classic agreements to fix prices, divide territory, or pool profits, and not simply market domination, which was what Standard Oil did. This meant that Standard Oil was not on their radar because there was no collusion between companies. It was just Standard Oil alone that controlled the market. Additionally, as Coleman explains, no federal charges were brought against Standard Oil because presidential administrations like Cleveland's and McKinley's were partners with huge businesses and had received campaign contributions from the company. As a result, many business owners were unhappy, not only because Standard Oil had monopolized the oil supply chain, but also because it used its power to undercut rival price, block pipeline access, and buy out competitors at unfair terms. Independent producers, especially those who wanted to enter the gasoline market to meet the growing demands of ICE, found themselves unable to earn profits and compete with Standard Oil. These grievances, along with rising public anger, eventually led the federal government to revive the long-dormant Sherman Act and put pressure on Standard Oil for ruining the oil industry. While Standard Oil was legally dissolved into 3-4 smaller companies, its legacy companies, mainly ExxonMobil and Chevron, continued to thrive in modern day, eventually becoming new supermajors. Sherman Act was not the only political impact of ICE. In Britain, the government passed transportation-related legislation in response to the increasing number of ICE-powered vehicles. The difficulties posed by cars on public roads were directly addressed by the Motorcar Act of 1903. It was the first time driver licensing and vehicle registration were made mandatory. Additionally, speed limitations for steam engines were modified to accommodate ICE-powered vehicles. These rules established the foundation for the current legal system that oversees modern automobiles.
So all in all, the internal combustion engine that started from Otto's 4-stroke design didn't just replace steam. It transformed how we live, work, and move today. By making power accessible and portable, new industries were birthed, economies were fueled, and millions of lives were changed. So the next time you hear an engine roar or see a car speeding down the road, remember behind every motion is a story of innovation, ambition, and profound change. The internal combustion engine wasn't just a machine, it was the engine of modern life.